Welcome back to Miss Burkhart's math class. Make sure you have your notes in front of you so you can fill them in as you watch the video. Pause the video if you need to catch up on the notes as you're watching. And remember, you can always go back and re-watch any parts that you weren't quite sure about just to make sure you fully understand it before moving on. So today we are going to start working on Standard 614B, solving one-step linear inequalities in one variable that involves addition and subtraction, and we're going to graph the solution on a number line. So that really is what we're going to learn today. We're going to learn how to solve one-step linear inequalities set with addition and subtraction, and be able to graph those solutions on a number line. So let's get started. We're going to compare how we solve equations to how we solve inequalities, because you've solved equations, one-step equations. So let's just review and go over this example here. To start off, remember what's the very first thing you do? Put a line down the equal sign, and then put a box around your x. Because remember, we want to isolate the variable, get it by itself on this side of the equation. And so what do we need to get rid of to isolate the variable? Plus 3. How do we get rid of plus 3 or positive 3? Subtract 3, or you can think of it as adding a negative 3 to both sides, right? To keep it balanced. Draw your line. So this became 0, and now we have to bring down the x, and we put our equal sign here. And what is negative 1 minus 3, or negative 1 plus negative 3 is, and you can do that on your calculator to check, and it is negative 4. So with equations, we get one value for x. X is equal to only negative 4. How would I plot that on the number line? Just literally put a dot right at negative 4. And that's it. There's only one solution to these equations. So let's check our work just to make sure we have the right value for x. So we put in the original equation. X plus 3 equals negative 1. Now, instead of x, we're going to replace that with the value we found, which was what? Negative 4. So now we're going to put in negative 4 plus 3. So what is negative 4 plus 3? Again, you can check on your calculator. It is negative 1. So then, yes, this did work out because we have negative 1 on this side is equal to negative 1 on the other. That worked. So now let's move over to a similar problem, but now instead of an equal sign, I have the less than sign. It's still the same, x plus 3 and negative 1 on the other side, though. So we solve inequalities using the exact same steps we did when solving equations. So we're going to still draw a line down but it's not an equal sign, it's an inequality sign. Still put a box around the x. You still want to isolate the variable. So we still have to get rid of what? Plus 3. How do we get rid of plus 3? We subtract 3 or add a negative 3 to zero it out, right? And we have to do the same to the other side. So you see how it's looking exactly the same here? These cancel. I'm going to bring down my x, but now here's a little different. I don't put an equal sign here. What do I put? The less than, because that's the one that's in the problem. Less than, and we still do negative 1 and negative 3, which gives you negative 4. So this is a little different. Now we don't have just one answer. We have an infinite number because it's all numbers that are less than negative 4. So let's list some possible solutions first before we graph it. What are some numbers that are less than negative 4? Can I use negative 4 as a solution? No, it's not in this case. That's remember, our boundary point. That's our limit. We can't go past that number. But what are some numbers that are less than negative 4? Well, we have negative 5, negative 10, negative 1 million. All those numbers are less than negative 4. So let's draw this on our number line. We've done this before. So our boundary point is negative 4. So I put a circle at negative 4. Is it going to be an open or closed circle? It will be open because this is not also equal to. This is our boundary point, but x can't be equal to. It doesn't have that line underneath. So I leave it open. Now we have to look and see, okay, well, what are the numbers? How would I represent this on the graph? Remember how we put dots on all of the solutions? But there's so many of them all in between there, we end up making it a line. So where are our possible solutions? -5 and -10. They are to the left of our boundary points. So you can put a little dot there to remind yourself. And so I'm going to draw the line, and remember to also draw the arrow, because that arrow, remember, represents all the numbers that are not physically on this number line, like -1 million and -10. So that's why we draw the arrow. So let's check it now to see, did we, first of all, did we get the right answer? And did we shade in the correct side of the number line? Let's rewrite the inequality. X plus 3 is less than -1. And we're going to replace it. Now we replace x, but can I replace it with -4 in this case? No, because it's all numbers less than -4. So what are some numbers that we chose? Like -5. So let's just do that and replace our x with -5. We'll put -5 in here. What is -5 plus 3? And remember, you can use your calculator, so it's -2. Well, let's see. Is this a true statement? Is -2 less than -1? Yes, it is. So this is a correct statement, so we chose the right side of the number line for our solutions. The one other example I'm going to show you is when we have our variable on the right side. Now, you've done that with equations, and it didn't matter which side it was on, right? We still solved it because you always, in equations, ended up with one answer. But with inequalities, remember, we have to be careful because we have infinite number of solutions, and when we're graphing it, we want to make sure we're getting the right values. So, same thing, just draw a line down the inequality sign, put a box around your x, make sure you're doing this on your notes as well. Now, what do I have to get rid of on this side? Because here's your variable on the right side now. What's on the same side as the variable that we need to get rid of? -4. How do I get rid of the minus or the -4? I'm going to add 4, correct? So, put +4, and if I add 4 to this side, what do I have to do to the other to balance it? Same thing. Good. All right, so this zeroes out. I'm going to bring down my x because that's what's left. Now, remember, I don't put an equal sign here. I put this symbol, the less than or equal to. And then we do -2 plus 4 gives us a +2. Now, this is where it can get a little tricky because you might see this less than symbol and want to make everything less than on your number line. First, let's put our boundary point. What is our limit here? 2. So we're going to put a circle at our boundary point at 2. And is it going to be an open or closed circle at 2? Closed, because this now it is equal to. So we're going to shade it in. But do you see where it can get very confusing if you're not careful? Because you say, oh, it's less than, so I must go to the left. No, because look, your variable is on the right side. So let's flip it. Remember how we did that? We're going to flip this one. So we'll put x over on this side now, and the 2 on the other side. What else do I have to flip? The symbol. So instead of less than or equal to, it's going to be greater than or equal to. So these mean the same thing, but this one just makes it a little easier to read. So now let's read it. X is going to be all numbers that are what? Greater than or equal to 2. So what are some numbers that are greater than or equal to 2? Well, look here. If we have 4 and 5, right? All of those are greater than, so that means we're going to go to the right and put the arrow just to show all the numbers that aren't physically on the number line, but all of those beyond it are part of the solution. See the difference? So when you have a variable on the right side, make sure you flip it before you graph it. So as we said, some possible solutions were 3 or 4 or beyond 10, right? And let's just check to make sure we put shaded the right side, the correct side of the number line. Let's rewrite the inequality. -2 is less than or equal to x minus 4. And now what are we going to replace x with? Can I use 2 in this case? Yes, because it is also equal to it. But let's choose one of our numbers over here. You can choose 2 as well if you like. Let's replace it with 3. And what is 3 minus 4? Be careful, that's not 1. You have 3 and you're taking away 4, so that's going to be -1. And let's see if this ends up being a true statement. Is -2 less than or equal to -1? Yes, it is. So that is a true statement, so we picked the correct side of the number line. Now it's your turn to try. This is a similar inequality, but be careful, this side's a little different. And you want to solve the inequality and draw the solution on the number line and check your answer as well, like we just did. So go ahead and pause the video and work on this, and then the quiz question will pop up. When you're finished, answer that, and then watch to the end. So welcome back. Now it's time to check your work. See how you did on your inequality, solving the inequality. So I'll give you a minute to look over it. In fact, just pause the video to check your work. Check to see. Now, if you didn't have these same 3 solutions, that's okay, as long as they were on the correct side. Pause the video and check it, and then when you're done, press play. Make sure you've made any corrections on your paper as well, and make sure you understand. If you did something incorrectly, that make sure you understand what you did. So, to recap, in today's lesson, you learned how to solve one-step linear inequalities with adding and subtracting, and you're able to graph the solutions on a number line. Great job. Make sure you keep your notes in your binder and bring that to class, and we'll see you next time. Bye-bye.